What is a matrix? A matrix is characterized by a dimension. A dimension is the number of rows and the number of columns. The dimension is the number of rows is m of Milan, and the number of columns is n of Naples. A Milan times Naples matrix is a table, an array with Milan rows and Naples columns, m rows and n columns. And obviously, we can read the rows as a vector. It's the way I introduce you to a matrix to represent a linear system. But also the columns are vectors. In an m by n matrix, the rows are vectors of r to the Naples to the n, and columns are vector of r to the Milan of r to the m, vectors with m entries. Dimensions are important, will be important. Actually, the dimension of a matrix, that in my case here, it's called, we will see that it's called matrix of the coefficients, will determine in part how many solutions at most the system may have. Let me state some properties of the matrices. Two matrices are equal if and only if all entries or respective entries are equal. We can also and easily define the sum of two matrices. In which way? Well, the entry of the sum of two matrices are the sum of the respective entries of the two matrices. But be careful. If you can sum two matrices if and only if they have the same exact dimensions. Also, because if they hadn't the same dimensions, this operation here wouldn't be well defined. You would arrive to some entry in one matrix such that there is a no corresponding entry in the other matrix if they add the same dimension. If instead they have the same exact dimension, you can easily do it. Oh, we can do better. Exactly as with the vectors, you can multiply a matrix by a number. How? Well, you multiply its entry, the coefficient of the matrix, by the number. What is more complex is the product of two matrices. Basically, first of all, the product of two matrices is defined if and only if the dimension of the two matrices are in a particular relation. So you have an M by N matrix, M by N matrix, and you can multiply, so product defined only if the first of the dimension of the second matrix is equal to the second dimension of the first matrix, N by P. And what's the way you make the product of the two matrices? It's called product also row by column. The ij entry of the product matrix is the inner product of the I row vector of the first matrix times the j column vector of the second matrix. Let's try to represent it here. So here you have an M by N matrix. So here you have, let's represent it through its row vectors. We have M row vectors, A1 and EM, where AI is in Rn. This is equal A. And this is for I equal 1, 2, M. And then here on the right, we have an N by P matrix. Instead of representing it through its row vectors, we represent it through its column vectors. So we have what? B1, B2, BP, where is our B, where BI is in Rn as well, because it has N column. Sorry, here I wrote something unnecessary. The comma here is not needed.